Welcome to today's show. I'm so excited. Robert, welcome.
Welcome to Innovation Red Bull. Innovation Coffee. Yeah, cheers, Alessandro. This is not a sponsorship.
I'm really excited about today. So today it's a whole new show. And I think before we dive into today's show, I think I just wanted to give a little recap about what we've done in the past week. I think some of you might have been with us last week. We've had actually 3 shows last week. So we had a bunch of shows because we had a big event, right? So we had the ARM Dev Summit, the big developer conference that ARM does once a year. And it was an amazing conference. I mean, there was so much content. I was actually, really stoked by all the amazing content that I saw on there. There was a lot of, tech talks, workshops, office hours, time to ask questions to experts, and it was amazing. And we had 3 episodes to actually talk to some of our guests that actually joined the Dev Summit. So it was a really interesting week. So we didn't have Innovation Coffee normal brew, but we had a special brew last week, right, Robert?
3 special brews. Yeah, and adding to what you just said, I think it's very important to note that all of that content is still available for free on demand. So if you go to the website that we just posted right there, devsummit.arm.com, you can still access all of this. So you just go through the regular registration process, and then all of that content is available on demand for you. So whether you attended and didn't get to see all the sessions you wanted, or you haven't registered yet and you want to go see what we're talking about, you can go check it all out there on the site. So yeah, I mean, it was awesome. So much cool stuff.
Yeah, and I think today is going to be even better, right? Because we've got Innovation Coffee Microsoft Azure special. So it's going to be all about Microsoft Azure. And we have the chance to actually talk to a really special guest. So let's bring our guest in, right, Robert?
Yes, please.
So let's bring in, hi, George. George Moore, Principal Program Manager of Azure Edge Devices. Hi, George. Welcome to the show.
Hi, how are you?
Very good.
Very good. Thank you.
Good to have you on the show. I'm really excited.
This is very exciting for me too. I'm glad to be here and broadcasting live from Microsoft headquarters in Redmond, Washington.
I'm excited to see that you actually have a nice setup there with your microphone on the stand and everything. It looks very good.
Yes, exactly. I decided to make the investment in having a more broadcast studio quality hardware simply because of the pandemic and the amount of teleconferencing and things that I was doing. So it's really nice to actually have good quality audio, video, and lighting and such.
It makes sense, and you can tell. That's awesome. Yeah,
it's actually interesting, how much actually people have. I think there's been in the last 6 months a lot of people that started streaming, right? And it's really interesting. I think we've upgraded all our streaming environments, except I'm stuck at home, so I'm not in the office, so you can tell from my couch out there. But other than that, got a new mic as well. But awesome. No, it's really great to have you on the show, and we wanted to give you a chance to introduce yourself, tell us who you are, what you do at Microsoft, and then we can get into more interesting questions.
Sure. Well, I'm George Moore. I'm actually one of the original co-founders of the Azure engineering team in 2006. And I helped design and build a lot of the core infrastructure of Azure over the last 14 years, specifically a lot of the compute infrastructure, the core lowest levels of the platform. And for the last 3 years, I've been focusing upon Edge AI, which is specifically around deploying edge inferencing of audio video scenarios at the edge. And we're actually excited to talk about the partnership we have with ARM, the use of our ARM devices, and give some really kind of interesting demos, some previews of some of the things that's coming very soon.
Yeah, and actually, we did touch on the fact that there was a big conference last week, but we forgot to mention. So I'm glad that you just mentioned it. There was the big announcement. That this is the whole point of this live stream, is that this is a follow up from the big announcement that happened last week, actually, around the partnership between ARM and Microsoft, right? So today is about really getting into the depth of what this partnership is, right? So that's That's why we're really glad to have you, George, and be able to speak about the details of this partnership and what it actually means for developers.
Absolutely. So the work we're doing in a co-development perspective with ARM is all about driving low cost inferencing of AI at the edge, so that you can actually capture audio video signals, do some really interesting AI routines on top, some convolutional neural networks, and be able to bring that back to the public cloud for further the output of that for further processing. And the announcement we made specifically with ARM is the work we're going to be doing together between Microsoft and ARM on helping to ease the toolchain issues that exist between primarily silicon and a lot of the complexities that exist today that can be assisted a lot by adopting cloud-centric architectures and tool chains to make it easier for developers to actually target these really interesting new silicon types.
Yeah, I added a link to this announcement below. So for all the stuff that George just mentioned, you can go read the announcement in this blog below. But it was definitely exciting news, and thank you for elaborating a little bit further on that. I'm excited to dive deeper.
Yeah,
absolutely.
And before we do that, actually, sorry, no, I was just going to say, George, I'm really excited. I think we chatted before about your experience, right? And you mentioned that you founded one of the engineering teams. I'm really excited. I'm really interested actually in hearing your kind of background story. Like, how did you get to where you are today? Like, what was your experience in the last few years? And yes, a bit of the background of what brought you here.
Sure. Well, as I said, I've been doing the Azure work for quite some time. And about 3 years ago, I decided that it was really interesting. Although a lot of great work was happening in the cloud, I could really see the next frontier as being at the edge. That a lot of really interesting things are happening from just from a data perspective. The fact that you can now affordably, in a very affordable manner, capture high quality and run high quality AI inferencing at the edge. But this turns out to be an incredibly difficult problem to solve, because you have these very capable now devices that can run at the edge. So how do you manage them? How do you update them? How do you update the firmware? How do you make them secure? How do you make them compliant? And everybody was really trying to get their arms around what that really meant. And so we actually started some early work in trying to figure out what are the scenarios that really matter for customers, what are the use cases, really getting close to the customers, taking, actually, in my case, schlepping hardware, putting hardware in suitcases. I would show up in the airport with these large suitcases full of Cat5 cables and zip ties and cameras off to different locations to deploy cameras and things, and actually get an understanding of what customers really want and the business case and the business outcomes that they wanted. So that was sort of the precursor to this. And it was incredibly painful. I mean, I won't lie that, being able to deploy that kind of hardware, manage it, update it with widely different network types, widely different lighting conditions, just how you physically have access to placing cameras, not to mention the privacy and the security aspects. I mean, I personally learned a lot, and a lot of that learning is now going into this work we're doing jointly with between Microsoft and ARM.
Sounds really, really interesting. One question, I guess, to follow up on that is, what do you think really, you said you've worked on this for a while, right? And it was really hard before. Do you see a tipping point? Like, do you see, are we at a tipping point, and why is that? Or is it a tipping point ahead of us? And, how do we get there? I guess, what is your view on the future of Edge AI?
Well, I do believe there is a tipping point happening right now as we speak, that there's now much more maturity in the overall IoT ecosystem, that IoT is a relatively well understood concept now. There's a lot of IoT developers. Microsoft has been making investments in our IoT stack now for over 5 years. So the maturity of the IoT ecosystem has really dramatically expanded and made a lot of progress in the last 3 years. And then coupled with that, layering on top of that is just the hardware from a AI perspective, that you have incredibly high performance, but low powered devices like the ARM, the A53 Cortex processor, that makes it really feasible to have small devices, not big, giant, heavy, noisy blade type devices, but small devices that you can actually run high quality AI inferencing at the edge and do so in a manageable and secure manner. So that's really, I think, what has happened in the last even 18 months is this tipping point. And that's one of the reasons we're making these investments. We're bringing out, and with our hardware partners, bringing out hardware devices that really make this easy.
I really love what you mentioned there. I mean, throughout even the before that, the last question, when you're talking about all this hardware at the edge, and you touched on security. I mean, as we start moving these devices out to the edge, and putting all this AI on there, analyzing things, and then pushing it up to the cloud, we're increasing the attack surface, right? And you mentioned the security aspect. I think it's really cool that that this is a focus, of course, but also looking back even further, right? We're talking about back in the day, all this data was streaming from the cloud out to the edge, bringing this data back into the cloud. You can't just backhaul all of this data. You need some analytics at the edge, right? To filter stuff out and analyze. And so, yeah, I mean, this is right up my alley. I'm loving this. So really cool.
Absolutely. So to address your first point, from a security perspective, the work we're doing is all centered around having hardware that has a hardware root of trust. So the device itself is manufactured in a secure manner. It's provably secure as it goes throughout the manufacturing chain, into the distribution chain, eventually to a customer, in this case, perhaps an enterprise customer. And the ability to take an AI model securely, download it to the device, and prove that the AI model that you built is in fact the same AI model that landed in the device. And the output, the inferencing output of that AI model can also be provably correct, in the sense that you can prove and attach certificates and other keys to the output itself, so that when it lands back in the cloud, you have the full round trip, you have the full knowledge of the round trip of the security of the overall model and the execution. Because frankly, there's, as you said, the attack surface goes up dramatically. And unless we take active steps, hardware-based steps to prove the output, this is not going to really take off.
Yeah, I agree. I think there's a lot of work that we're doing, and I think that it's the right work, right? And I'm really excited about this partnership. I think to get more practical, there are a lot of barriers that I still see, in the context of deploying this at scale, right? Could you maybe elaborate on your view? What are the barriers for developers today to actually deploy ML on device today, at scale efficiently?
Well, first off, I mean, at the center part is actually building an AI model. Today, it is still a very skilled set of almost artisan-like materials to build and train your own AI model. So we're tackling the problem in many different dimensions. One is making it super easy for you to build and train an AI model in the cloud using even no-code paths, such as Azure Custom Vision. So I can take a corpus of images, a set of images that I capture, and in the cloud tag them, train them, and build my own AI model without having to write any code. So the first problem is just building the AI model. The other problem is there's a host of downstream problems around. If you think about it, the AI model is just the center part of an overall application. And the application itself is comprised usually of multiple containers, at least in our case, the containers that run in the device, Docker containers. And each one of those has a version. Each one of those has its own DevOps lifecycle. And then you couple that with the cloud-based application that's consuming the analytical output. And it has its own version, its own output, its own lifecycle. And keeping all these in sync from a DevOps perspective and managing it, if you look at just the application, is incredibly complex. And so a lot of the work we're doing is around providing broad scale addressability, broad scale manageability of these devices, building on top of our existing IoT infrastructure that is quite mature and is managing millions of IoT devices today. But if you even take a further step back, just the application is even a small part of the problem, because you still have to manage the lifecycle of the operating system on the device itself, the firmware on the device itself. You want to do the ability of having over-the-air updates of the firmware, over-the-air updates of the operating system, so it has the latest security patches. And again, you can prove that the latest versions are there, that they're secure, and that the device continues to be secure. So the combination of having to manage the firmware, the operating system, the AI model, the application that goes around the AI model, the cloud application that composes with the AI model at the edge. I mean, there's a lot of moving parts, but we can really have traction on those now by a lot of the work we're doing, certainly as beginning in Project Santa Cruz, around building edge AI devices where Microsoft can manage the firmware, Microsoft can manage the operating system in a hands-free manner over the air, freeing the developer to use our existing tools to manage this DevOps lifecycle.
Yeah, it's really interesting. A couple of questions on your experience because you've got a background, kind of a mixed background between the embedded and the embedded world and the cloud world, right? Because I think you're really like bringing together these two worlds today, right? And I think my interest is trying to understand, who is our target audience? Do we see a world in which there's going to be ML engineers that have worked in the cloud, that are used to working in the cloud, that are going to start deploying things on the edge? Or do we see more embedded developers potentially like upskilling themselves to be able to deploy models in on edge devices? What's your view on that?
I think there's going to be a blending. I absolutely think that existing embedded developers are going to be increasingly compelled, and there's so much interesting things happening in the AI space in general, that being able to understand what it really means to build and manage and operate an AI-based device is, as you put it, an upskilling capability. And then also existing cloud developers who are used to Docker and Docker PS and device twins within the Azure IoT world from a manageability perspective, they're increasingly going to be very much interested in how they can build these AI models and deploy them, because at the end of the day, everybody's trying to solve these business problems. I mean, just counts of people, for example, people analytics, spatial analytics of people, social distancing scenarios. There's a wide variety of just increasingly off-the-shelf availability of these models that makes it possible and feasible in a very low-cost manner to actually make this work.
So, George, this might be relevant here. We did get a question on YouTube. This is from iShot JR. He's one of our frequent community members here. I'll put it up here on the screen so you can see. This is related to Azure Sphere. So he says, why did Microsoft create their own MT3620 Azure Sphere MCU versus leveraging existing targets? And he's speculating possibly security.
So we actually have made long-standing investments in Azure Sphere. And a lot of that work actually was an outgrowth of a lot of the attack surfaces we had, ironically, in Xbox and Xbox 360. So a lot of the lessons learned of how those hardware targets were attacked came into Azure Sphere. Now, that said, the work we're doing specifically in the Edge AI pieces is today not inherently tied to Azure Sphere. We're actually using different forms of hardware root of trust. But the key is the capability of being able to have provably correct execution of the models and provably correct output of the models that you can validate from a signing authority in the cloud.
I always forget. That's a great answer, by the way. I always forget that Microsoft is also Xbox, and I mean I'm an Xbox person. I think that's great that you can leverage. I mean, Xbox is kind of an edge device if you think about it. It has peripheral, yes. It communicates with the cloud, and so I mean I think that's great that you brought this up. I hadn't even thought about that, so that's awesome.
It's probably one of the more highly attacked edge devices that's in existence from a hacker community perspective.
Interesting. I bet both hardware, or attempting to hack, like real hack I'd call, but also social hacking, social engineered hacking as well. I'd imagine that there's definitely a lot of attack surfaces there. Cool.
Absolutely.
Yeah. Back to you, Alessandro.
I was just going to say, we actually got a comment on the chat from Carlos saying, interesting, hacking Xbox leads to better IoT hardware. That's what you just said. But no, it's super exciting.
True.
Go ahead.
No, it's absolutely true.
Yeah.
Cool. So we've talked about, in general, the announcement and some of the things that led to this announcement, right? I think it'd be interesting to actually now talk about what a developer could actually do today with Azure Edge, right? So I know that you've got some stuff to show us, so I'm keen to kind of dive into that. I'm excited, and I'm sure there's going to be a lot of questions around that. So
sure. So
take it away.
First thing, absolutely. So one of the first things I want to show is or talk about is Project Santa Cruz, which is building edge-based AI hardware, perception hardware for both video and audio. We haven't announced a lot of specifics about it, but there is a public website. If you go to GitHub, actually, let me share my screen here. And there is a Project Santa Cruz under Microsoft.com on GitHub, and it has some information about our public preview. There's actually a link in here where you can click and apply to get access to our private preview. And we actually have physical hardware devices. These are edge-based hardware devices that we are manufacturing right now, and you can actually get your own hardware device to start to, as a dev kit, to start to make use of this. And in fact, if you click in the URL here under user guides, there is a hardware link. And under here, there is a link for the data sheet for the dev kit itself. And as it points out here, there's both a eye system on module. We call it the vision system on module. There's also, we call the ear. These are all code names. They're not the final names. System on module. So it actually contains both AI processing for video as well as AI processing for speech. And it runs the entire Microsoft speech stack for the audio pieces, as well as it integrates with the Azure AI components and Azure Custom Vision from a video perspective. And actually, if you scroll down, there's information about the boards and the processor types, all the details about the hardware itself. It is built on top of an ARM 64 carrier board. The AI processor is an Intel Movidius Myriad X. So it's connected to an RGB sensor, so you can actually render and run your own AI models directly over the output of the RGB sensor. And as one example of that, I wanted to show in my own repo, I have a open source people counting application that we publish now that runs on the Santa Cruz devices. And so this is a completely free, completely open source application that actually does edge-based inferencing, does people detection. And it runs an example open source AI model, SSD MobileNet, that's been trained up with the COCO data set. COCO is common objects in context. And you can actually deploy this. If you click on the Deploy to Azure button here, if you have an Azure subscription, you can run this in a fully virtualized fashion in the public cloud if you don't actually have our hardware. So let me pause there and see if you had additional questions or wanted to dive in a little further.
I actually do have. Oh, sorry, Alessandro.
No, go ahead. I think this is exciting. So we both have questions.
Yeah, super exciting. I'll let you ask questions about the demo. I actually want to dive in a little deeper to, you mentioned this Azure subscription. You mentioned getting access to the hardware. I went to the website, great website. And I'm wondering kind of if you could touch a little bit on this whole subscription bit, because I did notice that there's this ability for you to get access to it pretty much immediately, start tying this in and deploying right to Azure. So could you just touch a little bit more on that subscription bit?
So you do have to have an Azure subscription in order to both use the hardware, the edge hardware we have, as well as run these example scenarios. But there are free tiers of Azure subscriptions. There are you have the ability of getting, if you don't have an Azure subscription, you can actually go get one for free. There's a one that has a variety of included quantities of dollars that you can actually spend on a variety of different Azure services. So it's not an impediment to actually, if you don't have an Azure subscription, it's super easy to go get one, get a free access, and actually start deploying some of these applications. And in many cases, these are, because a lot of the work is, from a hardware perspective, the inferencing and such is happening at the edge. You're not actually using a lot of Azure services until you actually start egressing the data back up to the cloud and storing the data in the cloud and such. So your free tiers can actually go quite a ways with this architecture.
Yeah, and there's a lot of features, by the way. So I mean, when you go check that out, there's a lot of free features and a lot of always free features. So I definitely
Yes.
recommend, you're developing and you plan on doing anything with this, go check that out because there's a lot of really cool stuff.
Right. So I wanted to point out here that if you do deploy this in the public cloud, we run this. You can have this example application run in one of two modes. You can run it fully virtualized, emulated in the public cloud. So it runs our developer kit, it runs the equivalent of our ISOM in the public cloud using CPU-based inferencing. But if you have the actual dev kit itself, you can actually run the exact same application with the same containers at the edge. The only key difference, of course, is at the edge with the hardware, it's based upon the ARM64, so it's ARM64 binaries. In the public cloud, it's x86 because we're using Intel processors in the public cloud. Intel and AMD. Have to be clear there.
I want to ask you a couple of questions before we go. If you go back up to this to the beginning of this, to the application itself, right? I was actually curious. Why did you pick people counting? I mean, I've got my views, but I think it's interesting, right? I think it's a really interesting application. I wanted to know your view on why you picked this application to start with.
So spatial analytics, specifically around people, is by far and away the number one customer requested feature. So the work we're doing here is very, very much customer driven. So unless a customer doesn't ask for it, we don't build it from an engineering perspective. And so we hear this across the board. It doesn't matter which industry, whether it's retail or healthcare or the manufacturing, being able to have access to counting people and understand where people are from a spatial location perspective is by far and away the number one scenario. Very simple examples, like, for example, counting people coming in and out of the door. So you establish a threshold, you count people as they traverse that threshold. That can lead to all manner of scenarios around, especially in this day and age, around the density requirements of different retail stores or manufacturing facilities. So it's by far and away the number one requested feature.
Yeah, and another question on this same topic is related to this actual demo. So I see there is some boxes that you could select. Could you better describe like what exactly you're doing there and like what are the capabilities?
Sure. So we're actually go here. So this is actually the app running on my Azure subscription. It's a Azure Web Services app. This is a stateless front end app that's simply reading the storage that's been sent from the edge device. So the app itself has no direct access to the edge device. Its rendezvous location is in the cloud using Azure Data Lake. And so if I actually click on then browse, it takes me out to the app. So this is the app running live, and you can see it's counting people. This is a little cafeteria. In this particular example with this open source app, I can create a new zone. So for example, I can drag, click here, and create a polygon region on the screen that is essentially the queue. So I define this 4-sided polygon region that will count the number of people within the queue, the length of time they've been in the queue and such. So this gives me all manner of analytical data about queue lengths, how efficient I am if I'm a retailer, how efficient I am. So there's some really interesting just base level capabilities, even in this free application. We are also developing paid commercial models that have even more capabilities from a people detection, people tracking, people in motion perspective. But this free application is still quite compelling just to get your feet wet in how to build such an application and deploy it between the edge and the cloud.
George, I'm amazed. In fact, I want this at every single conference that I go to, because I mean, I go to this BlizzCon conference every year. Obviously not this year, but the queues for the restrooms, the queues to go get another beer, the queues to go do anything. Imagine Comic-Con here in San Diego. Like if I'm watching a panel or something, I can pull up my app and say, oh, hey, it's a good time to go to the restroom right now, or it's a good time to go get another beer. That's awesome.
Yeah, I wanted to actually show this. So this is even more advanced. This is work we announced 2 weeks ago at our Ignite conference. So what I showed you before was an open source model, and it's pretty well understood from the state of the art how to do basic people detection, which is what that application does. This is even more advanced. This is what we are developing as a paid commercial model that not only does people counting, but actually can track the people as they're in motion. So in this case, you see there's different colored bounding boxes around the people, and the colored bounding boxes are durable as they move around the screen. That's because we're associating internally a reference for each individual person and associating that with the colored bounding box. And you also see the little trail. I don't know if it's visible there, but there's a little trail leading behind the different people. So in this case, I can also create a zone, a polygon region, and the system itself can tell me when people are in the zone, out of the zone, what the nearest vertices of traversal was if they entered or exited the zone. So there's a lot of great capabilities of this, but even more importantly, this has been written in a privacy-centric manner. It's GDPR compliant, it's secure by default, privacy compliant by default, and it runs on these same Santa Cruz devices that we've been talking about.
Very nice. So George, are you ready for another couple YouTube questions? Is that okay?
Sure. Absolutely.
Okay, perfect. So this, first of all, I want to point out iShot JR. He's like, yes, I applied, and the bomb looks interesting. So that's very cool. Puma 5K asks, are there any plans on the Santa Cruz kit for 5G connectivity and its features, private application slices towards Azure Edge zones?
So the dev kit itself has basic Wi-Fi connectivity, as you probably saw from the data sheet, as well as Ethernet. We're not announcing any future capabilities at this moment, but certainly there's a lot of really interesting things happening in the 5G space. And architecturally, to your point around edge zones, it makes more sense from an edge AI perspective, ignoring whether or not the dev kit has or does not have 5G. It's just the ability of having the inferencing happening literally in the store, the manufacturing facility, and your line of business logic running literally just a couple miles away in the neighborhood cell tower equivalent means that the round trip is under 10 milliseconds, which means you can really do almost zero infrastructure deployments of a lot of these scenarios, and not have to put a big amount of hardware in a small convenience store or even a large manufacturing or factory facility.
Awesome. I think that answers the question. Go ahead, Alessandro.
Yeah, no, I was just going to make a comment. I think the other really interesting thing with doing this people tracking on the edge, no matter how you do it, right? But like the interesting thing here is that you're not sending the people data, right, or the images of the people to the cloud anywhere, right? So you're just sending a number, and even from an efficiency, kind of power efficiency perspective, cost, you're only sending a number each
exactly,
whatever milliseconds or seconds, and it's quite it's quite interesting because I think maybe even a couple of years ago this was not even thought of, right? I think you talked about before a turning point, right? I think this is becoming possible, and it's amazing. It's unlocking a lot of possibilities.
Absolutely, you're absolutely correct that we're taking a very high quality video stream at the edge, and we're essentially reducing it down to a series of JSON packets that represent the individual people. That is completely devoid of any privacy information. We're not doing facial recognition. You don't have to do any of that stuff at the edge. You're just really keeping track of where the people are. They're offset within the frame and having the ability to do analytics on top of that. And even like in this example here, because we're actually in our paid models, we're doing full pose detection. So we're actually able to compute essentially a skeletal map of people as they walk around. So in this case, we're able to compute the absolute distance between people in a frame. So for social distancing perspective. So you see here, the lines between the people are based around basically their hips, which is kind of their center of mass, not the outer edges of the bounding boxes. So a lot of really interesting capabilities, and it really hints the amount of processing power that's at the edge. That you can, to your point, that you can actually now do this at the edge. And there's about 30 CNNs that matter in the world, and we can run, in fact, most of those today on very low cost devices, very low cost, but yet high powered devices at the edge.
Yeah, and I mean, another point that you touched on earlier that I wanted to kind of ask you about. You said there's different ways to run this model at the edge, right? You said you could do the inferencing on AI accelerators or on CPU, on the CPU itself, right? So can you elaborate on that? Like it's an interesting thing to me because for years people have thought that they need big cloud servers or big and powerful computers to do machine learning, but actually it's becoming more and more apparent that actually you can do a lot of computation on CPUs, right? So what is
Absolutely.
your view on that? And
no, that's actually a great point, specifically around ARM, about the ability to actually run these same ML models, the same AI models on an ARM processor without even any other form of hardware acceleration is now feasible. And I personally have taken some of this code and run it on the ARM64 processor. It works. I mean, it's obviously not as fast as if you have dedicated hardware acceleration, but the fact that this, very small, very low power, and by power I mean from a power consumption perspective, not power from a processing perspective, this device can actually do a lot of these hardware-based, a lot of AI inferencing is astonishing to me. And I see all the time scenarios where you don't need necessarily a big high-powered device to do people detection. A very simple example is there's tons of legacy gauges and knobs and other readouts in the world, steam gauges, analog gauges, and having just a simple camera that can point at a steam gauge or a pressure gauge and convert a 1950s analog meter into a digital output is very, very affordable now and very feasible. And being able to do that with an ARM processor specifically is not just feasible, but it's achievable.
Yeah, and I think what's really interesting is that we've seen actually use cases of exactly what you're saying, like retrofitting old devices with a little camera running actually on a Cortex-M. So even beyond we talked about here Linux devices, right? The A53, the Cortex A53 that you mentioned, but actually we've seen cases in which you could run it even on lower,
absolutely,
even more low power devices. And I think we're at a point where we're doing things that were impossible a few years ago, as I mentioned before. And I think we're really unlocking a lot of innovation, and I'm really curious to see what developers come up to. So if you're watching this, sign up to Project Santa Cruz, because I think there's a lot to explore here.
Absolutely.
Yeah. Robert, should we take the other questions from the audience? Actually, I think I just saw another one.
Do you mind, George, if we take a couple more YouTube questions?
Of course.
Okay, cool. So one comment before the question, Puma 5K brings up that casinos are a great example of where data generated by people and data on people has to stay on premise. So an edge compute use case is perfect for such a scenario. I can imagine many other places where that would be important, but yeah, I mean, definitely casinos. So onto a question here. This is from iShotJR. He says, does Azure have any ARM native or native ARM-based cloud a la Graviton?
Not in the public cloud at the moment. So the work we're doing at the moment is entirely edge-based with ARM.
Okay, I think that answers that.
But I wanted to address the other point as well around both edge-based processing and edge-based storage of the analytics, and that is exactly spot on. There's many scenarios like a casino or other even HIPAA examples in healthcare where you don't really want to egress. In some cases, you're prohibited from egressing data, even non-PII data like this, outside the physical confines of a hospital or a doctor's office or something like that. And being able to record the AI inferencing, and potentially with some of these other use cases around recording the video, but at the edge still, so that it's a very common scenario, like in a convenience store, you want to do local DVR, local recording of video, and being able to actually take the video and the inferencing and combine it together and store it at the edge with no cloud interaction is certainly very feasible.
Nice. So this is the last question here that's on the chat so far, and this one is from another one from iShotJR. And this was when you were kind of going over that convenience store. He posted this question. Says, so there will be models as a service, and he seems pretty excited about that. I'm guessing available through this program.
Yes. In fact, that's exactly what the point I was trying to convey, is that we're making investments in first-party commercial AI models that both Microsoft as well as our ecosystem partners are building. And both we will sell those as well as third parties will sell that. We We will have the ability where you can build your own AI model. You can put it in our marketplace, and you can download it to our devices and use it, as you said, models as a service. So you don't have to be an AI developer. You can be an application developer that composes these pre-built, pre-trained AI models.
I love this idea, especially when you look at like, I mean, okay, there's the marketplace and that's awesome and people can go consume these as a service, but it also might bridge into kind of the open source space where people build these foundational use cases, something that may not be all the way there, but the foundation to build upon, and someone could post that and then consume it and, you know, add their layers that they want to add to it, making it more unique to their specific purpose. So I think that that's just awesome.
Well, that's exactly what I did here. I mean, in this example, this people detector is a fully open source people detector. Yes, I have the commercial one, and we can embed the commercial one to get additional capabilities. But from a free open source, you know, it may be good enough for many different scenarios. And the fact that these are readily available and consumable in a very easy to digest manner is quite compelling.
Nice, very cool. JR likes it too. I shot JR likes it as well.
I think, going back to this, now you brought this back up. What's interesting is, for example, we see some low power connectivity like LoRaWAN, right, that have little bandwidth. But actually, if you're just sending number of people, you're fine, right? So you could potentially use some low power connectivity technology to actually send around just the number of people or the number of objects. I'm thinking even like in other situations like traffic, or you could send a number of cars or things like that, right? So it's really interesting. I think this type of application is very it's got a lot of different use cases. It's
right.
Super
yes.
interesting.
If you look at, in fact, the JSON output of some of these models, it's incredibly simple. You have basically an identity of a number representing some individual. You have the XY coordinate, the bounding box, and frame offsets within the camera image itself. And that's about it. If you have zone detection going on, you may have zone entry exit information, but the total payload is less than 100 bytes uncompressed. And you compress that down, and it compresses very well before being sent up to the cloud. So both the transmission and the storage in the public cloud is trivial. In fact, if you think about it, video itself, even though most people don't egress the full video stream, the fact that cloud storage is so cheap nowadays, I can take a video camera output, like for example from the Santa Cruz device, and I can store the full video feed from that for less than $1 a month in the public cloud, if you had the need and if you had the egress bandwidth. But so it's there's a wide range between small number of bytes for just the people, from an AI perspective, all the way up to a full motion video feed.
So George, we've talked about the hardware, we've talked about the features, we went through this demo. I'm kind of curious about resources now. So developers are watching this, and they have access to your GitHub. We've provided them links to all this stuff. I noticed that there's an amazing learning hub directly through this program that you can go there, and you can also get certifications. So I'm kind of curious, would you mind sharing a little bit more about, this learning hub and the certifications that are available for developers?
Sure. Actually, one of the beauties that we're doing here from an AI perspective is we're layering on top of our existing Azure IoT infrastructure, which has been around for more than 5 years. So we have a very rich array of training certifications, both people certifications as well as device certifications, that we are logically building upon to add these AI capabilities. So absolutely, you can go today and get certified on and trained up on the basic Azure IoT capabilities. And then it's a relatively small step from that on to actually having an AI model. In fact, it's literally just deploying an additional couple of containers on the edge device, and away you go. So we also announced 3 weeks ago device certifications for these devices themselves. And that's an increasingly important part of the work we're doing to ensure that the devices themselves perform the way customers expect, that they're secure, they're compliant. So there's both device certification as well as people certification available.
Thank you. That's awesome.
Very interesting. So you mentioned about deploying containers to the device, right? And I think one really interesting aspect here is so I come from the embedded, the kind of microcontroller space, right? So I come from really little things that don't run Linux, so that you cannot deploy containers on. And what's interesting is that I think for a while, embedded developers have been not really using cloud native approaches, right? They've been using standard approaches where you write a piece of C code and you just end up, like writing it as firmware in your device. I have a feeling that that's changing. So I want to hear your view. Is there an uptake of this cloud native approach in embedded? What's your view?
Well, absolutely. In fact, that's the crux of the announcement, the joint announcement we made between ARM and Microsoft, is the ability to take a lot of these tool chains that have existed and really make them work much better by moving them into the cloud. So you don't have for example, all the configuration problems. They're already pre-configured. It's easy to take, for example, an AI model, have it down converted into targeted devices or targeted for very small devices that, as you point out, may not have a full container, may not have the ability to run a full instance of Linux with Docker, for example. So the ability to innovate within the tool chain is really the ability then for existing embedded developers to be able to take advantage of some of these cloud native concepts and very readily use them to attack these new class of problems for these new class of devices. But as you point out, not all these devices are going to be very capable, very high power. They're still going to have a large number of tiny embedded devices that still have a great deal of AI capabilities. And so how do we address that market?
Yeah, very interesting. I think, the reason why I was so excited to have you on the show and to talk about this is because, I really think this partnership can unlock this making it easier for developers to deploy AI models on device, right? And I think I'm really excited about the next steps, right? I wanted to give you a chance again to share with everyone. There's additional people that have joined. So can we share again the Project Santa Cruz? So maybe, you've got the link there. I'm going to just open it.
There we go. Yes. So it's github.com/Microsoft/Project Santa Cruz preview is the GitHub repo. It has the getting started guides, hardware specifications, links to sign up to get your own actual dev kit. And we can ship one in the mail to you and you can actually use it. And it's a we've designed a very smooth process to be able to unpack the device, unwrap it, and have AI model execution within 10 to 15 minutes. So, incredibly smooth from a setup perspective, all the way to doing no-code type, very compelling no-code type development using a lot of the cloud-based tools we have today around Azure Custom Vision and such.
I encourage anyone who's we saw iShot.jr. You said you applied, but I encourage anyone who's watching that does get one of these kits to come show us what you build on the show in a later episode. So, that would be really cool to see what you end up building. And Alessandro, we vote for this, but Alessandro and I will have to vote and we'll get you on. And what do you think, Alessandro?
Sounds exciting. George is going to have to come back though. If we do that, we want George as well.
Of course.
Are you happy for that, George?
And you can use, I published the full source code to that people counting application that I showed you before. So you can take that, adapt it for your own scenarios, even replacing it with your own AI model or building on top of the basic people detection. If you actually go out and look at COCO, the Common Objects and Context dataset, there are literally hundreds of different object types that are already pre-classified, pre-tagged. You can bring those down. We publish in our GitHub repo Jupyter notebooks for how you can actually build and train your own models for cup detection versus dog detection. So you can really make this your own. And I would love to see the resulting output of people trying building models in this manner.
And you mentioned, I think you showed me last time actually that you can actually pick where to deploy the model on, right?
Yes.
I think you got that choice at some point. Was it in the?
Yeah, it's right here. So when I touched upon a little bit of the DevOps piece, the thing I really didn't talk about too much is the deployment model. In some cases, deployment, especially of these blended edge and cloud applications, can be very complex. But this is actually an example you can also use yourself of using an Azure Resource Manager template to be able to programmatically, in a hands-free manner, deploy all this complexity under the covers, so you don't, from a hands-free manner. And so in this example, if you click on the Deploy to Azure button in that people counting application, we actually have CPU targets of x86 or ARM64, and then AI inferencing. You can choose either CPU-based inferencing, NVIDIA T4 tested inferencing, as well as Intel Movidius Myriad X inferencing. So if you actually click on Edit Template, you can see under the covers how we actually did this. This is the deployment template, how we can then pick, based upon what actions the user took, we can pick which containers get downloaded. And this is actually part of the, in fact, I'm going to show off a little bit here. If I go into pipelines, this actually shows the Azure DevOps pipelines for how we manage the different versions of the different components and how we match those up with the actual deployment models. So we're trying to make this as easy as possible to showing example code that you can take and readily adapt.
Awesome.
Very nice.
We've actually got a question from Robert that shared it on the chat.
I was saying I'm surprised that no one's asked this yet. I was curious when we were doing our dry runs, even I was going to ask you, are you by chance related to Gordon Moore from Moore's Law? Okay.
No.
All right. That would be cool. But I mean, yeah. Silly
That
question.
started a whole new conversation.
Yeah.
I've only been doing software, not deep in hardware like the other Mr. Moore has been doing.
Gotcha. Cool. So is it time now? I think we have about 6 minutes left. We usually give an opportunity. Do you have any more questions in the chat? If anyone has any, we can get another couple in there. Otherwise, we kind of go into the shameless plug, if you'd like to call it that, something that you'd like to share with us, the last minute take on what's going on and what you would like to, final notes. What do you think?
Any questions? Happy to do the shameless plug. Shameless plug
We
is
haven't got any more questions coming in, so I think we can go for your shameless plug.
the shameless plug is go sign up for the Santa Cruz Development Kit. Click on the link in the GitHub repo. Give us your name and address. We'll get you a kit in the mail, and you can start to play with this yourself and make use of this really compelling set of software that we've designed to work very well together.
And we will make sure that every single thing that we've shared so far today, thank you, by the way, George, everything that we've shared, we'll make sure that those links end up in the description of the video. So if you missed it, if you don't think that you took a screenshot at the right time, don't worry, it's below, copy paste it and go explore everything that we talked about today. George, awesome. Yeah. Awesome live stream. I really appreciate it. This has just been great. Thank you so much for taking the time to do this.
Thank you.
Yeah, thank you for sharing all your knowledge. It's really, what I find really interesting. I didn't mention this before, but people see you got a blue shirt, looks very, very professional, and then you've actually got a GitHub repository where you're putting code yourself, right? So I think that's awesome. So thank you for sharing that. I think it was really interesting to know that your whole experience, how you got to this, and what you've done so far. I think was really interesting.
Thank you.
So thank you.
Great. All right. So time to close it out then.
Time to close it out. Yes.
All right. So next week's surprise episode. Stay tuned. We'll definitely update you through the ARM Software Developer Twitter. Once again, I just want to thank you, George, for joining us, and all the viewers out there. If you have any questions, you know where to find us on Discord, Twitter, here on the channel. Don't forget to like and subscribe to us. Over to you, Alessandro.
Well, no, a big thank you. I just wanted to reiterate a big thank you to George. Thank you for joining. And thank you for sharing all the amazing stuff that you've been working on. And again, thank you all the viewers. Any last word, George?
well, I can't claim credit for all this. There's a team behind all this. So let's be clear that I'm not the sole developer on this project.
Well, thank you
Awesome.
to all the
Yeah,
developers as well. Yeah.
I was going to say. So thank you for all the developers working on this then. Thank you very much.
Thank you.